Hello everyone, today let's solve the problem number 190, reverse bits. So what the question states here, we are given a 32-bit in 1 second. We are given a 32-bit unsigned integer and we need to reverse in bits. So that's what they have given here. So we are given a 32-bit unsigned integer and we need to reverse its bits. So the result should be a new unsigned integer whose bits are in the reversed order. So the result should be a new unsigned integer. You can clearly see in the example that they have mentioned here, right? So the output, so till here, new unsigned, the result should be a new unsigned integer whose bits are in the reverse order of the original integer. So we have to get the reverse order of the original integer, this one as output basically, right? Reverse order of this one basically. That's what they have given in the question. So let's come to the first one here. So here we have this one given. So what should we do? Basically we have to reverse its bits, right? So first we will reverse its bits and result is basically an unsigned integer, right, whose bits are in the reversed order of the original integer. So this one we get basically when we do this one, right? So the input binary string, this one, the input basically represents the unsigned integer. This one represents the integer 43261592. So right, so this one, basically they have given the binary string as input right here. This one basically this represents the integer 43261596. So we have to return this one. So this one as output because the binary representation is this one. Binary representation as this one, right? So we have to return the output 964176192. This is fine. Let's come to the second example here. Second example we have as this one and the output that they have given here as this one. This is fine. So I hope this is completely clear. So I hope the question is completely clear. What we need to do is completely clear as well. First, let's discuss the approach and then let's write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So the first thing that we need to keep in mind here is we will be going with the bitwise reversal. So this one I'm speaking of, the approach I'm speaking of basically. We will be going with the bitwise reversal using iterative bit extraction, right? So the binary string we have is this one. And when we convert this one integer, we get some number. When we reverse its bits, the result that we get here is this one, 964176192. So this one we need to return this one as output. So the output that we got is 964176192. So that's what we have already discussed this one, right? Let's move on with the step-by-step execution here. So first what we will do, we will start from the least significant bit, means rightmost, and take one bit at a time and append it to the results left side, means the last bit. Suppose this one, just for the example, right? Suppose we have this one as this is binary format of some number. So what we will do, we will take the rightmost bit and we will append it to the left side. That's what we do. That's what the statement says basically. Most significant, we start from the least significant bit, rightmost, take one bit at a time and append it to the results left side, nothing but the most significant. So the second step here is we do this 32 times. So we will be doing this 32 times, building the reverse numbers bit by bit. So we will do the same thing. Let's see the same thing. Let's see the iteration here. The first iteration when I is 0. So this has to be from I equals 0 to I equals 31, as we have 32 bits, right? So as index is 0, we'll do till 31, right? So we have to go with the 32 iterations mainly. So result left shift operator equals 1. This one result is 0 basically. N and 1 and means we are performing bitwise AND, right? This one is the left shift operator. So n ampersand 1 is 0, means nothing added here. N right shift operator equals 1. We have this is right shift operator, right? This becomes this one. The result becomes this one. So next step here is we are having this one 0 and we will append this one to the left. The second step result, same step will be carrying on here, and this case we'll append the last 0 to the left, this one left side, right? So we will repeat the same process till I equals 31, appending bits to the left. taking one bit and appending it to the left. The rightmost, taking the rightmost bit and appending it to the left side. That's what we do until till I equals 31. Means 32 iterations, right? So the final answer after 32 iterations we get as this one basically, right? Which is equivalent to 964176192. So the output that we got here after 32 iterations is, all the 32 iterations I cannot show. I have showed the first 2 iterations. We have to go with the same thing. So after 32 iterations, we get this output basically, which is equivalent to the integer, this one, 964176192. When we convert the binary format to integer, unsigned integer, this one, right? 964176192, which is equivalent to the output that they have given for the example 1 in the question. So the output here is 964176192. 964176192. So this is the output that we got here, right? So this is the output that we got. So the output that we got is equivalent to the output that they have given for the example 1 in the question. So as we are completely familiar with the approach, let's go with the let's start writing the code. So the first step that we'll be doing here is, let's initialize the result, right? So here we need to store the result somewhere. So I'll just go with the result. So initialize the result to 0, not the array. So this is fine. We are just initializing the result to build the reverse number basically. So let's go with the next step here. We have to loop 32 times, right? Constant time here. So we have to loop 32 times for 32 bits. I'll just go with a simple for loop here. For int I equals 0, I less than 32. So let's increment the I here. So within the for loop, what we will do, we'll be making use of the left shift result to make the space for next bit. Also, we'll add the least significant bit of the N2 itself. These two things we will be doing. So first, let's make use of the left shift result to make space for the next bit. We have already seen this one in the approach. So I'll just go with result left shift this one. This is fine. So the next step is, we have to add the least significant bit of N to the result. So I'll just go with here result equals n ampersand 1. This is fine. So the final step here is, within the for loop is unsigned right shift. We'll be making use of the unsigned right shift n to move to the next bit. We saw this one as well during the approach, right? So I'll just go with unsigned right shift. We have to go with, right, equals 1. So this is fine. So the final step is, we have to return the reverse bits as an integer. So that's what they have asked in the question. So first we need to convert the binary. We have to reverse all the bits. Then we have to return that one as integer, right? So in this case it will be, we are storing in the result. So I'll just return the result. So this is fine. So this is it for the code. Let me format this one once and hit the run button. So let me enlarge this one. What we are getting here, error entering component. So let me hit the run button again. Wait a second. Let me copy this one. What happened to this one? So let me hit the run button again. So yeah, you can clearly see, I don't know what happened. After reloading, this is working. Basically, the sample test cases are getting passed. So let me hit the submit button very quickly. So you can clearly see here, all the test cases are getting passed. Means the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is this one, bitwise reversal, right? Using the iterative bit extraction. We know this one. So what would be the time complexity? So here the time complexity would be big O of 32. So why it is big O of 32? Basically, we are going with a constant time because we are just looping 32 times here. In this case, you can clearly see we're just looping 32 times. We have discussed this one during the approach as well. So the overall time complexity would be big O of 32 in this case. So what would be the space complexity here? The overall space complexity would be big O of 1. Why it is big O of 1? Because we are making use of the constant number of integer variables, right? We are just making use of constant number of integer variables. So the space complexity would be big of 1. The time complexity is big of 32 and the space complexity is big of 1 for the code that we have written. I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear as well. For now, this is it. Thanks for watching, guys.